Assalamu alaikum students, this is Farwa Batool, your O-level computer science instructor, and welcome to another video on the topic of identifying errors in algorithms. In this video, we are going to do activity 7.16. But if you haven't watched my previous video of identifying errors in algorithm, please go ahead and watch that because in that video we did activity 7.15, which is too much related to this video. Now, let's have a quick background of what we were doing. Look at this. This is a pseudocode we were working on, a flowchart. On your left hand side, we were working on this flowchart, and the purpose of this flowchart is to identify the highest and the smallest values in your test data. So look at here, variable B and C. The values of variable B and C will be your output. B is going to have the highest value of your test data and C is going to have the smallest value of your test data. I'm not going to explain you this flowchart. If you want to understand this, please go ahead and watch the previous videos. In activity 7.12, we saw that when the test data is greater than 100, then the values that are output, the algorithm is finding the highest value, but the algorithm is failed to identify the smallest value. The smallest value was not 100. In this test data, the smallest value was 110. But since the value was, all the values were greater than 100, that's why it was unable to find out the smallest value, which was 110. Why is it so? Because look at the initial values for your variables B and C that are set by your pseudocode over here. Now, let me explain you this. Variable B was set to 0 and C was set to 100. And B is a variable that is going to identify the highest value or store the highest value of your test data. C is the variable used to store the smallest value of your test data. Since all the data is greater than 100 in this example 7.12, all the data is greater than, test data is greater than 100. That's why the smallest value is greater than 100. The smallest value of your test data is greater than 100. Sorry, I need to change this sign. So 100 is less than the smallest data that we have. That's why the variable C can never be modified, because C has already the smallest value that is even more smaller than your test data smallest value. Or in other case, 100 is less than 110, which is the smallest value of your test data. That's why you cannot modify variable C. I hope you are getting my point, because already I set the variable C to the more smallest value than your test data smallest value. That's why variable C will never be modified in this example. Now quickly see that how the algorithm, the same algorithm will work for the negative test data. In the negative test data, we are done with this activity in the previous video. If you want to see how we did the working of it, please go ahead and watch that. Now I am moving towards the results here. Look at my output result. When all of my data is negative, then the highest value here is 0. 0 is not part of your test data. It means the highest value is not identified. It's wrong. It's not been identified by the flowchart. Whereas the smallest value in my test data was -40. It is correct. The smallest value was detected, but the highest value, which was -2, was not detected. Why? Because again the same thing. The range that you set for your largest value is if the value is greater than 0, if b is going to be greater than 0, only then you can identify the largest value. If the largest value is less than 0, in this case, if minus 2 is my largest value to be identified, which is less than 0, which is not greater than 0, then you are failed to identify that. Because what you have did, you have initialized your variable b with the largest value larger than the value in your test data minus 2. So you cannot modify your variable b in this case, because b has already more large value than your largest value in the test data, which is minus 2. So if you will see that is minus 2 greater than 0, it will be false. The largest value to be identified is less than 0. So only we came to the conclusion here that only if your test data is within the range of 0 to 100, only in this case, this pseudocode is going to work. This pseudocode is only designed for the test data that will be within the range of 0 to 100. Only then you can identify the highest and the smallest values. So, keeping this in mind, we came up with a better algorithm. And the only thing we have changed here is that range. Now, variable b was initialized. Instead of 0, you are initializing variable b with a more negative value, minus 1, 0, 0, 0, 0, 0, 0, a very much negative value. So if your highest value, keep in mind, if the highest value to be identified is greater than minus 1, 0, 0, 0, 0, 0, 0, then you can definitely identify, or the pseudocode is definitely going to identify that value in your test data. Same goes for variable c. Variable c was initialized with 1, 0, 0, 0, 0, 0. So all the values in the test data, let's suppose if the smallest value of your test data is smaller than this number 1, 0, 0, 0, 0, 0, 0, then you can easily identify your smallest value of test data. The range must be satisfied. Your test data must be in the range of these two numbers that you are setting for your variables. Look at here. Again, the problem will be the same. If the test data is not within the range of these two numbers, then there will be some error. Either you will not be able to identify the highest value, or you will not be able to identify the smallest value. Now, look at activity 7.16. In this activity, what you have to do, identify two numbers where the algorithm will still fail. This is just as we did for the range of 0 and 100. We saw that if the value was less than 0, the highest value, then you cannot identify the highest value. And if the smallest value is greater than 100, then you cannot identify the smallest value. Now, same goes for this example. Let's write down the range first that we have set for the smallest variable and the largest variable. The variable b was set to minus 1, 0, 0, 0, 0, 0, 0, and variable c was set to 1, 0, 0, 0, 0, 0, 0. It's a positive number. Now, b is going to identify the largest value of your test data, and C is going to identify the smallest value of your test data. And keep in mind that these two values are already being set by your flowchart for your largest and smallest variable. Now let's suppose if the largest value of your test data, if I consider all the values in my test data are less than minus 100,000, all values are more negative than this number, then it will be impossible for you to detect the largest value. Why? Because it is just same as when you set 0. Then if the test data is less than 0 or you have negative test data, so you cannot identify the highest value. Same goes for this example. Let's suppose if the largest value in my test data to be identified is, let's suppose, minus 1, 000,001. This is more negative than this number, smallest. Whereas in my test data, this is the largest value to be identified. But it can never be placed in variable B because variable B has as the largest value, more largest value than this largest value of your test data. Because when you are going to check for the condition says that if the value of x is greater than the value of variable b, only then you can change variable b. And when this largest number in your test data minus 100,001 will be compared with the value of variable b minus 100,000. So this statement is going to be false. Variable b has the largest value than the largest number in your test data. It is set with the largest value, initially set with the largest value than your test data value. So you are unable to identify your largest value in the test data if all the values are more negative than this number. So if we have, the first thing I will say here is if minus 100,001 is the largest value in your test data, to be identified by this flowchart, then it will fail. The flowchart will fail to identify. And why it will fail? Because the reason is because variable b value, the variable b is set to a greater value, than minus 100,001. So that's why variable b will not be modified. Or to make it more clear, you can simply write x. When x will be checked for this condition, x greater than b, and the value of x is minus 100,001, which is your largest test data value, it is not going to be greater than minus 100,000, which is the initial value set in variable b. this condition will be false. So you cannot modify the value of variable b. So this is, I hope that you understand this point. Now same goes for the other number. If we see variable c, let me just quickly move it from here to make you understand this. Variable c has initial value 10000000. It's a positive value. But let's suppose your test data values are greater than this number. Then let's suppose the smallest value to be identified is 10000005. Let's suppose this is your smallest test data value to be identified. You have more test data values, but this is the smallest one to be identified by the pseudocode. In this case, you will not be able to identify the smallest value of your test data because it is beyond the range. It is greater than the value you set in variable c. Or in other case, if I'm going to check for the condition, if x is less than c, only in that case, you have to change the value of variable c. And when your test data value, the smallest test data value, which is 10000005, will be checked under this condition, then this condition will become false. Why? Because this smallest value is not smaller than this value. Since it is not smaller than the value that is initialized in variable c, that's why it will not be modified. Variable c will not be modified with this smallest value. I hope you are getting my point. Let me just write it down in the wordings over here. Number 2. This is basically the solution of your activity 7.16. If, let's suppose 10000005 is the smallest value, in your test data to be identified by this flow chart. I'm just copying it. Then it will fail to detect the smallest value because the reason is the same, because variable c that is used to identify the smallest value is set to in this case smallest value, I will say, not the largest value, is set to a smallest value then minus 100. Oh sorry, it's not a minus, it's plus 5, this value. Or I can write the condition x less than b, whereas 10000005 is not less than 10000000. Let's not write down c, b here. We are working with variable c. So this condition is going to be false. That's why your smallest test data value will not be replaced, or will not be, placed in variable c. So these are the two values that will make this algorithm fail. This value, if it is the largest value to be identified, and this value, if it is the smallest value to be identified by the flowchart. So again, the thing is basically this new or modified algorithm is only going to work if your test data values are within this range that is set in two variables. Thank you so much for watching this video. I hope this video is going to be helpful for you. If you didn't subscribe the channel, please go ahead, subscribe it, and stay tuned for more informative videos. Take care. Bye bye.